This morning's .com talk is going to be about an aspect of global warming that many have not considered. That is the um, nature of uh, temperature changes on frozen water, ice. Um, if you take an ice cube and put it on the table, it melts if the room temperature is uh, above freezing. Um, if the room temperature is, let's say, 33 degrees Fahrenheit, the ice cube melts slowly, but eventually it converts to liquid water. But it does so slowly. Um, it doesn't just suddenly become a puddle when you put it on the table. Um, well, if you raise the temperature of the planet, then uh, the ice on the planet melts and flows away. Uh, Water seeks its own level. So when we raise the temperature of the atmosphere on the planet, we cause the ice on the planet, some of it, to melt. But it does so slowly over time, not instantly with the change in temperature. If you take an ice cube and float it in a glass of iced tea, uh, the ice cube eventually melts, assuming the the temperature of the tea is above freezing. And we make that assumption because it's liquid and the ice is floating in it. The level of the tea in the glass is not changed, and when the ice melts, the ice converts to water, and the ice being less dense than liquid water um, floats. So when the ice cube displaces a certain amount of water, and when the ice converts to liquid water in the tea, it doesn't raise the level of the tea in the glass. Uh, if you take an ice cube and suspend it above uh, the level of the tea in the glass and let it melt, then it drips into the glass, and the level of the tea or the liquid in the glass rises proportionally to the volume of the water, the liquid water in the ice cube. Um, so if an ice cube's floating in a glass of tea and melts, it doesn't change the level of the liquid in the glass. If you suspend it above the tea and let it melt into the tea, the level rises proportional to the volume of liquid water contained in the frozen water, which is the ice cube. This seems fairly basic, but it applies to both the North and South Pole, the Arctic and Antarctic. The ice in the Arctic is just frozen seawater or frozen water, some of it being from snow and frozen rain. But it's floating on the top of the ocean. It is not sitting on land mass. So when it melts, it doesn't affect the level of water in the ocean in any way. whereas the ice cap in Antarctica, for the most part, is sitting on a continent, which is Antarctica. And when it melts, the water then runs off into the ocean. And like the ice cube that melted and suspended above the iced tea, this water, this frozen water in Antarctica, when it melts, runs into the sea and raises the level of water in the sea. The two main repositories of frozen water on this planet that are on land masses are the ice cap on Greenland and the massive ice cap on Antarctica. So when these ice caps melt, they raise and flow into the sea. They raise the level of water in the oceans, and that is distributed around the planet uniformly due to the fact that water or liquids will seek their own level based on their liquid nature and gravitational effect. Anyway, the point of this is that we have already raised the temperature of the atmosphere in this planet, and it is having an effect on the glacial formations around the planet, as well as the ice caps in Greenland and Antarctica. But the full effect of the raising of the atmospheric temperature has not been felt yet and won't be felt for some time. But as we can be certain that as we raise atmospheric temperature, ice will melt and ocean levels will rise. The only way to slow this process down and possibly stabilize it is to stop the atmosphere from heating, and the only way that I can think of that we can do this is by reducing the production of CO2 created through the burning of fossil fuels. So we need to be aware of this fact and do what we can to stabilize ocean levels for the sake of future generations of humanity, as well as other life forms that are being affected by climate change.